Thanks for introduction. Hello, I'm Yiqin from HCR Lab in Tsinghua University. Today I'll introduce our work typing on Shuyi keyboard with peripheral vision. So Shuyi keyboard are widely used on handheld touchscreens, especially tablets. So as iPad, as Microsoft Surface or Samsung Galaxy Tabs. It split the conventional keyboard into two halves and located them on two corners of the touchscreen. So the user can grip the device and use his thumbs to tap on each part of the screen. Like he can use his left thumb to tap on the left part of the keyboard and the right thumb to tap on the right part of the keyboard. So in these settings, the Shuyi keyboard have some benefits compared to the conventional keyboard. First, this allows the user to have a steady grip posture of the keyboard of the devices, so he can use it while walking or lying down. Second, it occupies less area of the touch screen, so it leaves more spaces for other components. Third, two-thumb typing is more efficient than one thumb or one index finger. And the users receive a lot of training during his daily smartphone uses. So, however, a Shuyi keyboard suffers from the weakness. That is, the user have to switch his attention back and forth between the text feedback and two keyboard halves. This not only causes more eye and head movement, but also limited the typing speed. So our motivation is to solve this problem by attention switching and to improve the experience of using Shuyi keyboard. This is video clearly shows how users type on a Shuyi keyboard. We can see that his eyeballs and head have obvious movement because he has to look at the left to right and the right to left, which costs much time and effort. Our idea is to type with peripheral vision, or we call it peripheral typing. That is, the user focuses visual attention at the text feedback and keep two Shuyi keyboard in his peripheral vision, like this picture. This typing mode doesn't require user to switch attention frequently between these parts. In this work, our contribution is to explore and understand this typing mode. Okay, with no knowledge of typing with peripheral vision, we raise three questions. First, can users type with peripheral vision? Previous works have investigated the feasibility of eyes-free typing. And their answer is yes, the user can actually type without any visual attention. So we guess the answer is yes. So the second question, what's the performance of peripheral typing? If the performance is promising, then the third question is how to make peripheral type practical. That means how can users peripheral type on a real text input task? To answer the first question, we conduct the first study. The goal of this study is to collect data for analysis. We need data to prove that user can actually type with peripheral vision. We use the Samsung tablet and develop an Android application on it, like this picture. And we recruit 18 QWERTY users who use their smartphones QWERTY keyboard every day. And the task for them is to transcribe 40 random selected phrases from McKenzie's phrase set. And because we have no algorithm now, so we use a Wizard of Oz experiment that we fake the real typing experiments. We always show the correct letter whatever user touch on touch screen. It feels so intelligent, so user types in a very natural way. We collect typing data in three conditions: eyes on, peripheral, and no keyboard. Eyes on is the conventional typing mode. We know that the user allowed to switch his attention between these parts. And the name of eyes on is derived from the eyes free. Peripheral is the typing with peripheral vision, and the user is only allowed to look at the text feedback. And no keyboard mode is that we hide the keyboard. So it's the baseline condition of the peripheral condition that we want to know the effect of a peripheral vision. So the results, collect data results is shown on the picture, in the picture, and this is intuitive. We can see that in eyes-on condition that the data contributions are very compact, that you can see each distribution is within each key. And in peripheral vision, the distribution are much larger, and there are some overlaps between neighbors. In no keyboard condition, there are super large overlaps between neighbors, and we cannot even know which the key is. So there are, if there's no keyboard, then due to no reference, users are very free and fly their thumbs on the keyboard. So that we can see that distribution is far away from the central. But if we have a peripheral vision, that we can constrain our typing within the keyboard. Okay, we still need more powerful evidence for the feasibility, so we use collect data to run a simulation. For more details, please see our paper, and the results is we compute the top K accuracy. That is, we predict K candidates with a higher possibilities, and if the correct word within this top K, then we compute we say it's correct. And you can see in eyes-on mode that obviously there are nearly 100% accuracy and in peripheral mode, we can see that it has over 90% accuracy on top one. That means over 90% of words we can predict once. And surprisingly, with so naive algorithm, we have the peripheral typing have about 99% accuracy on top 5. That means if we offer 5 candidates, then the user can almost select his words inside the list all the time. So now we want to know the second question: what's the performance of peripheral typing? So we conduct the second study to evaluate the performance. We recruit 18 quality users and to transcribe 40 random select phrases. And at this time, there are differences that we have algorithm now. So we provide a selection method for user to select words from the candidate list. We consider 2 conditions, eyes-on and peripheral. In eyes-on mode, we place the candidate list right above the 2 keyboard halves. This is default setting on many commercial tablets. And it makes sense because the user can see the keyboard. So the candidate is right here. In peripheral mode, it's totally different. Then we place the candidate list near the text feedback, and we provide top 5 words because it's enough. The problem is the user cannot reach the candidate list, so we designed an indirect selection method that the user drag on the touch screen. The process is the user first touch on the touch screen, then move the word, then release to confirm. The average speed you can see in the picture that the peripheral mode significantly outperform eyes-on mode with 28% increase. That was because user type more fluently and casually in peripheral mode. In this video, we use an eye tracker to track user's gaze in typing. We can clearly find that in this video that peripheral typing user's gaze is fixed at the text feedback. But in normal eyes-on typing, user's gaze is switching between different parts. This proves that the typing with peripheral vision actually reduces the attention switching. Also, we show the gaze heat map. So, all right, peripheral typing is fast and user-friendly. So, can we throw out the eyes-on one? Unfortunately, not, because peripheral typing has some defects. First, user have to learn about the QWERTY layout, but it's not really a problem because sometimes learning is necessary. But the most important problem is that peripheral typing strongly rely on the language model, which means the user can only input word in the dictionary, but for out of vocabulary words such as names or address, user cannot type with peripheral vision. And I think this is a common problem for algorithms use language model. But in eyes-on mode, you can type anything. So the question is, how can we combine these advantages together? Can we detect peripheral typing or eyes-on typing? So our solution is to put them together at the same time. So we designed GlanceType. GlanceType supports both eyes-on and peripheral mode at the same time. There are two kinds of lists. One is just near the text feedback, which is the candidate list for peripheral typing. The other is located on the region above the keyboard, like conventional split keyboard. So what's the benefit of this design? This is because GlanceType allows the user to freely choose eyes-on or peripheral typing mode without mode switching. Two candidate lists are visible simultaneously, so the candidate user want to select only depends on user's intention. When the user wants to type in peripheral mode, he can just drag and release to select word from the list. In this case, he doesn't require to switch his attention. When the user wants to input an out-of-vocabulary word, such as his name, he just type on with eyes-on typing, and the literal character screen is shown above the keyboard, and the user can easily tap on it. This means you can type anything. And the punctuation symbols and digits are also be supported by eyes-on typing mode. Then we designed a swipe gesture for users to switch from the alphabetic keyboard to punctuation keyboard. So to answer the third question, how to make peripheral typing practical. The goal of this, we conduct the third study, and the goal of this study is to figure out what people will do when it's free to type. And the corpus we use is changed now. We use the email, dialogue, and the Twitter datasets as our corpus, and because these are all typical tablet scenarios. We evaluate GlanceType with no peripheral vision and a commercial Samsung keyboard at this time. So the results show that GlanceType has higher speed in entering all the word overall performance, and also GlanceType has 7% higher speed than the commercial keyboard. This shows the potential of use GlanceType in our real life, and we also provide other results in our paper. So we answer all three questions, and a new question comes. First, how much feedback is more efficient? We explore the peripheral vision. It's a intermediate mode between no vision and full vision. So how much visual feedback is enough, and which visual feedback is best? Second, how's the peripheral typing in other conditions? We only evaluate in the landscape mode of the tablet. And what about portrait mode or typing on big tabletops or large displays? That's our limitations and our future work. Okay, that's all my talks. Thanks for listening, and welcome questions.
Cool, thank you. If there's any questions in the audience, just raise your hand. There's SVs with a microphone. So, okay, I can ask a question first while you think of some. Okay, I had some written down here. Okay, first one. So did any of the was there autocorrection during any of the studies? And if not, how were participants dealing with any mistakes they made?
Pardon?
Like autocorrection for typing, was that enabled during the studies? Okay, so was there a sense that participants were making mistakes often, or?
It depends. We told them to type as natural as possible. So sometimes the mistake happens.
Cool. Yeah. Okay.
To do something? Oh, it works now. Yeah, so I'm Martin Locke from Strathclyde Uni in Glasgow. In your studies, the keyboard was always visible? Yeah? In the peripheral vision view?
Yeah.
Did you think about, and you instructed your users to look at the text input area? Yeah? Did you think about ways of, so when I'm using a tablet, I'll be looking at the keyboard, and I will naturally, I think, start looking at the keyboard. Did you think of ways that the interface could encourage me to stop looking down there?
Yeah. I think this depends on the. It depends on the user case, because in some scenarios we can drag the split keyboard up and see that the split keyboard and the test feedback can in line. So in a line, so that's easy for us to type. But in some cases, that's using maybe search engine that you type on the test feedback, and there will be a long list and very various pictures around. So the keyboard can be is better to locate it in the corner.
Okay. So I might have missed this. How many of your participants were touch typers?
Touch type for the physical keyboard, but they don't have experience touch type on the touch screen.
Okay. Did you actually ask or assess that? I know that I've actually started getting quite good.
Yeah.
The more
People sometimes just type on the keyboard without looking at the keyboard. That's part of the peripheral vision that we investigate the full peripheral vision. That's different.
Okay, cool. Is anyone else near the back of the room that want to ask a question? We can run out and give you a microphone. No? Okay, well, I think that we should thank our speaker. So it's lunchtime just now. There's also in the town hall, there's a town hall lunch in room Lomond. And that concludes this session. So just thank you to all the speakers again.